Okay, so part B says g of x is x over x squared minus 3. So to find domain, set the bottom equal to 0. And we get x squared is equal to 3, which means that x is equal to plus or minus the square root of 3. Because when you take the square root of 3, there's no perfect square that gives you 3. So that's your domain is going to be all real numbers, except x is equal to, you could even write it like this, plus or minus square root of 3. And that would be your domain. So for vertical asymptotes, here's what you want to do. You want to plug them in. So when you plug them in, let's go ahead and plug in the negative one first. So f of negative square root of 3 is negative square root of 3 all over negative square root of 3 squared minus 3, and that gives you negative square root of 3 over 3 minus 3, which is number over 0. So x is equal to 3. I'm sorry, x is equal to negative square root of 3 is the vertical asymptote. Let's try the other one. F of square root of 3. So it's going to be square root of 3 over square root of 3 squared minus 3. That's square root of 3 over 3 minus 3, which is number over 0 again. So both square root of 3 and negative square root of 3 are vertical asymptotes. So let me write here, vertical asymptotes. Horizontal asymptotes, HA. So we look at the function. Is this function bottom heavy, top heavy, or same degree? Well, if you look at the power, this is an imaginary power of 1. The bottom is 2. It's bottom heavy, and all bottom heavy answers have a horizontal asymptote of 0. So, and you should always answer it as y is equal to 0 is your horizontal asymptote. And x-intercepts. Let's see if I can squeeze it in here. Let me do another color. To find x-intercepts, we set the y equal to 0. So we're going to set g of x is 0 is equal to x over x squared minus 3. And if I want to get rid of the bottom, if I want to eliminate the denominator, I want to multiply both sides by what the denominator is. So that goes away. This is 0, and x is equal to 0. So that means that 0, 0 is my x-intercept. And y-intercept, I'll use blue. Whoa, no, that's not blue. Y-intercept, we set the x equal to 0, so it's going to be g of 0 is equal to 0 over 0 squared minus 3, which is 0 over negative 3, which is still 0. So your y-intercept is 0, 0, which is the same thing as your x-intercept. So both of these x-intercepts and y-intercepts are at the same point. Next one. Okay, so now we have another function. So let's go ahead and do this. Domain, always set the bottom equal to 0. It's too early in the morning. Domain, set the bottom equal to 0. So x squared minus 4 is equal to 0. X squared is equal to 4, and x is equal to plus or minus 2, which means that your domain is all real numbers except x is equal to plus or minus 2. Your vertical asymptotes, we're going to plug them in. When you plug in negative 2, you get negative 2 squared minus 3 times negative 2 all over negative 2 squared minus 4, which is positive 4. A negative 3 times negative 2 makes it a plus 6 all over 4 minus 4, and that is number over 0. So far x is equal to negative 2 is a vertical asymptote. Let's try positive 2. 2 squared minus 3 times 2 all over 2 squared minus 4. And that gives you 4 minus 6 all over 4 minus 4, and this is still a number over 0. So x is equal to negative 2 and positive 2 are your vertical asymptotes. Horizontal asymptotes. Look at this function here. Bottom heavy, top heavy are same degree. They're both the same degree. So what are we going to do? We're going to divide the imaginary positive 1 and positive 1 together. So your HA is 1 divided by 1, which is 1. So y is equal to 1 is your horizontal asymptote. X-intercept. What do? We set y equal to 0 and we solve. So multiply both sides by the denominator. Well, what happened in part A and B? Whenever we multiply both sides by the denominator, the bottom always went away. So the trick to finding x-intercepts for rational functions is whenever you have a rational function and you want to find the x-intercept, just set the top equal to 0, because that's what always happens. If you saw in letter A and letter B, that was what was always happening. So set the top equal to 0 and solve. Now you still have a quadratic, so you still have to factor. What is common in x squared and 3x? X and x. So I'm gonna factor in x. And if you want to make sure you factored right, you can go to the side and be like, okay, let me check if I did it correctly. X times x, x squared. X times negative 3, negative 3x. Okay, good. So far I did this right. And then you're gonna separate and solve. X is equal to 0. X minus 3 is equal to 0. You separate these two and you set them both equal to 0. This becomes x is equal to 3. So you have two x-intercepts, 0 and positive 3. So that means that your x-intercepts in point form should be 0, 0 and 3, 0, just in case your professor wants it in point form. For y-intercept, you set the x equal to 0 and you solve. Okay, so let's do this. So f of 0 is equal to 0 squared minus 3 times 0 all over 0 squared minus 4, and this becomes 0 on top, negative 4 on the bottom, and that is always going to be 0, so that's 0. So your y-intercept, y equal to 0, or in point form it's 0, 0. And you could use one of these two answers depending on what your professor wants. Letter D. Letter D, now we have a little bit more difficult problem, just a little bit more, not a lot. So let's go ahead and find domain. Domain, we're going to set the bottom equal to 0, so the bottom equal to 0. And then now you have to figure out what two numbers that multiply that give me 1 right here, and two numbers that add, the same two numbers that add that gives me 1. Well, what two numbers always gives you 1 when you multiply? 1 and 1, and when you add 1 and 1 you get 2. So I found them. It's x plus 1 and x plus 1. Set it equal to 0. Well, that means that you have x is equal to 1 and x is equal to, I'm sorry, not equal to 1. X is equal to negative 1 and negative 1. You have two of them, so really you only have one answer. You only have to choose one answer. You could erase the other one because they're both the same answer. So this is my domain. My domain is going to be all real numbers except x is equal to -1. Now let's go ahead and find your vertical asymptotes. What do? We're going to plug them in. Vertical asymptote. So we're going to plug in -1 into your function. So g of -1 is -1 squared minus 5 times -1 plus 6. No, not plus, minus 6. All over -1 squared plus 2 times -1 plus 1. And this is going to be positive. Negative times a negative is positive. Minus 6. This is going to be 1 minus 2 plus 1. And if I add them all, it's going to be 6 minus 6 over 0, which is 0 over 0. And according to our notes, 0 over 0 is a point discontinuity, not a vertical asymptote. So, what does this mean? This means that you have no vertical asymptotes here because you have no more other numbers to check. No vertical asymptotes. Now let's do horizontal asymptotes. This should be easy. Same degree, top and bottom. We're going to go ahead and just divide the numbers in front of the x, which is an imaginary 1 divided by an imaginary 1, which is 1. Y is equal to 1 is your horizontal asymptote. X-intercept. Set all your set y equal to 0. So set y equal to 0, or like we said in part C, set the top equal to 0 because that's what always happens. The bottom part always goes away. Set the top equal to 0, and let's go ahead and factor and solve. Two numbers that multiply that give me -6, but when I add them gives me a -5. So two numbers that multiply to give you 6 is 1 and 6, 2 and 3, but it's -6 and the 5 is also negative, so they both have to be negative numbers. No, I'm sorry, the bigger number has to be the negative number. Okay, so it's -6 and +1. -6 and +1. When I multiply 1 times -6, I get -6. When I add 1 and -6, I get -5. So it's x minus 5. I'm sorry, not minus 5. X plus 1. I chose 1, and x minus 6 for the -6. Okay, so my factors are x plus 1, x minus 6, which means that my x-intercepts are x is equal to -1 and +6. Those are my x-intercepts, or in point form it's -1, 0, 6, 0. For the y-intercept, I'm going to do this in red. Y-intercept. For the y-intercept, we have set the x is equal to 0. So g of 0 is equal to 0 minus 0. I'm plugging 0 for every x, and it's just 0 minus 6 all over 0 plus 1, and that is -6 over 1, which is -6. So my y-intercept is 0, -6. Last one. Okay, let me go ahead and do the last one on a separate video because I don't want to make the videos too long, because I don't know if YouTube can take videos longer on my account, longer than 15 minutes. So last problem, Valeria.